Okay, we're going to talk some more about factoring today, specifically some hints and some strategies we can use to factor better and faster and more accurately. So here's a quick refresher on factoring in a pen that is way too large. We factor as a different form of standard form. So here's a quadratic expression that I'm going to factor. My first step is to multiply a and c. 2 times negative 15 gets me a negative 30. I'm going to write out the factors of a and c. Negative 30 and 1, negative 15 and 2, negative 10 and 3, negative 6 and 5, negative 5 and 6. And then they all repeat. So negative 3, 10, negative 2, 15, negative 31. Negative 1, 30. We should switch that around. I want to find the pair of factors that add up to b, and my b term is negative 7. Well, the pair of factors that add up to negative 7 is negative 10 and 3. So I'm going to take this negative 7 and split it up into a negative 10x and a positive 3x, because negative 10x plus 3x is still negative 7x. Now, the 2x squared is still here, and the negative 15 is still here, and I can factor. I'm going to factor by grouping. So I slash this right in the middle, right in half. Out of the left half, I can pull out a 2x, leaving me with x minus 5. Out of the right half, I can pull out a positive 3, leaving me with x minus 5. And that gives us 2x plus 3 times x minus 5. That's factored. Okay, that is factored form. One of the things I want to talk about is why this trick of combining these two into one parenthesis and these two into one parenthesis, why that trick works. That's the grouping part. That's called factoring by grouping, really, right there. So I want to show why that works by talking about distribution. So here's the same factors, 2x plus 3 times x minus 5. I'm going to go through and do the distribution of 2x plus 3 times x minus 5 and kind of show how these are similar. When we multiply these, we tend to do 2x times x, and then 2x times negative 5, and 3 times x, and 3 times negative 5. And that's correct. That's fine. What we can also do is I can think about this as being 2x times this whole parenthesis. I can think of it as being 2x times the whole thing x minus 5, and 3 times the whole x minus 5. Then I distribute, and I get my 2x squared minus 10x plus 3x minus 15. And then I combine my like terms to get 2x squared minus 7x minus 15. And notice how these steps, if I call these steps 1, 2, 3, 4, perfectly match these steps 4, 3, 2, 1. It's the exact same thing, just one is written forwards and one is written backwards. So grouping is recognizing, hey, this x minus 5 appears twice. I can basically factor it out and see what's left. And I know that's really hard to visualize. I'm going to try and show it one more way, and we're going to move on. But look at this line. Okay, I have 2x times x minus 5 plus 3 times x minus 5. What if instead of having x minus 5, what if I just called that like a big old capital A? Then what I have is 2x times a plus 3 times a. I'm going to rewrite this as 2ax plus 3a. And I can factor the GCF of a out of both of these. I can factor out that thing they have in common. The thing they have in common was a, but a is actually x minus 5. So there it is. That's factoring by grouping. You don't need to understand all the stuff I just did, but I wanted to explain it so that you could maybe give a shot at it, try it, think about it. I love explaining why things work. I think it helps students remember it and use it better in the future. Okay, let's talk about some other strategies. I want to talk about how we can find the factors of a times c very quickly and accurately. So remember, when you factor by grouping, your first step is to multiply a times c. Here a is 4, b is 16, c is 15. Well, if I multiply a times c, that's 4 times 15, which is 60. 60 has a lot of factors. The numbers 1, 2, 3, 4, 5, and 6 all go into 60. That's why our time is base 60. Like our clock has 60 minutes, 60 seconds. The Babylonians loved the number 60 because so many things go into it, and the Babylonians were one of the groups that made the first clocks. You know, had a good calendar, had good timekeeping. I don't think they made an actual clock, but they had very, very solid timekeeping for their era. Well, here's the best way to make sure that you get every single factor of 60 when you write them down. Take 60 and divide it by increasing numbers. So like 60 divided by 1 is 60, but 60 divided by 2 is 30, and 60 divided by 3 is 20. And if I keep on dividing 60 by increasing numbers, pretty soon I've covered them all, because 7 doesn't work, and 8 doesn't work, and 9 doesn't work, and we've already covered 10. So we don't have to write it again. So you should just start with your number and divide it by 1, then divide it by 2, then divide it by 3, and divide it by every single number until you've looped all the way around. And it turns out that looping all the way around usually happens pretty fast. So there's all the positive factors of 60. Then I just switch all their signs if I want the negative factors. You get the idea. Now it's easy to find the pair that adds to 16. It was this one. So I would split this 16x into a 6x and a 10x. And I would have 4x squared here, and I would have 15 here, and I'd cut it in half, and I'd pull a 2x out of the left half here, and pull a 5 out of the right half, and get 2x plus 5 times 2x plus 3. And there's my factoring. So you multiply a times c, and then you write out all the pairs, or all the things that can multiply to a times c, and you do that in order. Let me do another example, and I'll talk through a couple more strategies. So I'm going to do x squared plus 43x plus 120. 120 is going to have a few more factors than 60. Actually, not a lot more, but a few more. So my a value is 1, my b value is 43, my c value is 120. Let's talk about some ways to do this. I know that 120 can divide by 1, no problem. I know that 120 divided by 2 is 60. 120 can go into 3 can go into 120 40 times. And now I start doing some tricks. Suppose I'm not sure if 4 works. I know it does, but pretend like I wasn't sure if 4 could go into 120. One thing I could do is think, if I double 2, I can cut 60 in half and get 30. In fact, this means that 8's going to work, because I can double 4 to get 8 and cut 30 in half to get 15. So 8 times 15 is 120. And now I also know 16 isn't going to work, because if I double 8 to get to 16, I can't cut 15 in half. Like 7.5 times 16 is 120, but this isn't a whole number. 7.5, which is half of 15, isn't a whole number, so that's not going to work. But if I double this side and cut this side in half, I can keep generating more and more pairs. Same with triples. I can triple one side and cut the other side into a third and keep generating more and more pairs, if I wanted to. But that's usually not necessary. So if you're going through your factors, right? So we're going to get 5 and 12. No, we're going to get 5 and 24. 5 times 24 is 120. Well, since this right here is an even number, I can cut it in half and double this and get another pair. And since this is an even number, I can cut it in half and double this. And that's an even number. I can cut it in half and double this. And I already had 3 and 40, so I didn't have to write it again. But these are just some little tricks you can use to generate more and more factors, to calculate factors quickly. Here's the last set of tricks for finding factors, and that'll be it for today. Oh, for the record, this was 40 and 3. If I'd picked 40 and 3, right here, 40 and 3 is how I would have factored this. This is going to be x plus 40, x plus 3. When it's all said and done. I didn't do the grouping steps there, but it'd be 40 and 3 when it's all said and done. Okay, I want to talk about rules of multiplicity, because this is something that I've found that not all students have learned and is really, really handy. Here's what this means. Rules of multiplicity means how you can tell if a number can be divided by something. Like, we know that an even number can be divided by 2 because it's even. But really what that means is, if I have a number that ends in 0, 2, 4, 6, or 8, then it can be divided by 2. There's rules like this for most numbers. The next one is one that, if you haven't learned this before, like if no one has ever taught you this, that is a major problem with your math education. This is something that you should have learned a long time ago. So it's not your fault if you haven't, unless maybe you weren't paying attention when they were teaching it. But here's how you can tell if a number can divide by 3. I know the number 216 can divide by 3 because if I add up its digits, the actual numbers 2, 1, and 6, I get 9, and 9 can divide by 3. If you add up the digits of a number and you get something that can divide by 3, the result can also divide by 3. Like if I take 216 and divide it by 3, I'm going to get a nice, clean, pretty whole number. Let me show you. Oh, opened up a calculator twice. Let's clear this. 216 divided by 3 is going to be 72. Sweet. If I take the number 1,248, I'll just keep going. This, if I add up the digits, 1 plus 2 plus 4 plus 8 plus 0 plus 9 is 3, 7, 15, 24. 24 can divide by 3. How do I know? Because 2 plus 4 is 6, and 6 can divide by 3. So this number can divide by 3, and it comes out clean. $41,603. If your numbers can't divide by 3 when you add them up, so 17 is 1 plus 7, and 1 plus 7 is 8, and 8 can't divide by 3, then the number can't divide by 3. So it's that simple. So the trick for 3 is super, super convenient. The trick for 4, there's 2 ways to think about it. If you want to tell if a number can divide by 4, there's 2 ways you can do it. One is just look at the last 2 digits. If the last 2 digits can divide by 4, then the whole thing can divide by 4. So if I have this number, well, 14 cannot divide by 4, so this whole thing cannot divide by 4. This trick is useful if the number is kind of small, but not that helpful for something like this. You probably aren't sure if 76 can divide by 4 by just looking at it. Turns out it can, but I had to think about it for a second. So here's the second trick. This one is also like not super helpful in all cases, but if a number can divide by 2 twice, it can divide by 4. So for example, 60 can divide by 2 once, and then it can divide by 2 again. So 60 can divide by 4. Kind of obvious, because dividing by 2 twice is the same as dividing by 4, but it can be helpful. If you divide a number and you get something even, it can divide again, so it can be divided by 4. But 370 divided by 2 is 185, and that cannot divide by 4. This cannot divide by 4. Okay, 5s are super easy. The 5 trick. If the number ends in 0 or 5, obviously, no problem. The 6 trick is just the 2 and the 3 trick put together. If a number is even and can divide by 3, it can divide by 6. So for example, this number is even, and if I add up the digits, 2 plus 1 plus 6 plus 2 plus 4, I get 3, 9, 11, 15. And 15 can divide by 3. So this number can divide by 2 and by 3, so it can divide by 6. It can also divide by 4, because 24 can be divided by 4. So that number that I just made up on the spot can be divided by 2, 3, 4, and 6. It can't divide by 5. Okay, there is a trick for 7s, but the 7 trick is not that useful, so I'm going to skip it. There's also a trick for 8s, but the 8 trick is not as useful, so I'm going to skip it. So I'm going to show 2 more. I'm going to show the trick for 9s, because it's really cool, and show the trick for 11s, because it's crazy cool. Here's a trick for 9s. If you add up all the digits, this is my 9s trick. Uh, 9, 16, 18, 24, 25, 27. Add up 2 and 7. It comes out to 9. If a number can be divided by 9, then every time you add up its digits, it can also divide by 9. It'll actually be 9. So I'll make up another one. When I add up these digits, 3 plus 1 plus 5 plus 6 plus 2 plus 0 plus 1, I get 4, 9, 15, 17, 18. Ha! 1 plus 8 is 9. This number can divide by 9. So the 9 trick is like the 3 trick, but more precise. It has to come out to exactly 9, and then it can divide by 9. And of course, if something can divide by 9, it can also divide by 3. Okay, 10 trick is obvious, ends in 10s, ends in 0. Duh. The 11 trick, really, really, really fun. This number can divide by 11. Here's how you can tell. If you add up every other digit, 2 plus 7 plus 0 is 9. 1 plus 8 plus 0 is 9. They're the same. So when I take this number and divide it by 11, I'm going to get something whole. Sick. Whereas if I added one number to that, 217802, if I divide this by 11, I'm not going to get a whole number, because that number can't divide by 11. I'm going to do another one. Real long number. 8, 12, 15, 16. 3, 4, 12, 16. This number can divide by 11. I'll just show that one also because I get so excited about it. 6, 3, 2, 1, 4, 8, 3, 4, 1. This divided by 11 will be some whole number. Yep, a very, very big one, but it's whole. So why am I showing you this? Because now when you multiply A and C and you're trying to find all your factors, it's going to be easier for you to determine if something can divide by 3 or can divide by 4 or can divide by 6 than it would have been otherwise. And that'll make it easier to factor, and that's what we're going for here. Okay, so here's my recap. Find all the factors of a number by dividing it by consecutive integers like 1, 2, and 3 until you have them all covered. Understand and know your rules of multiplicity, and just keep practicing to get better at factoring. Boom, way to go.